Hi, we're going to do part 3 or question 3 of paper 2, and we're going to split this into 2 parts so that we can have a shorter video as we go along. I thought this is easier and more accessible for you. So let's dive into question 3, doing the first part of the question. So this is only 7 marks in total, but we're going to split this up into 4 marks first. Alright, so here to understand the context, this is only going to happen in paper 2, and this is based on the concept of solubility. Okay, so they are telling you that these teachers try to make a saturated solution of potassium permanganate. If you have come across this color or this chemical, you will know that it is this dark purple in color. Alright, so this teacher is trying to add this volume of water to a temperature of 50 degrees Celsius. And what's going to happen here is she's adding one spatula at a time until the solution gets saturated. So the first question is coming in and they ask you define the term saturated solution. Okay, most of them have the idea of what saturated solution is, but they find it a challenge to pen it down to words. But so how do we come across this question? If you simply want to say no more solute can dissolve in a saturated solution, you actually can get 1 mark. Interesting, isn't it? Alright, but if you want to be more precise, you could say saturated solution is a solution that contains maximum amount of solute in a given volume of solvent. Okay, so this is the most accurate way to describe saturated solution, but again, it's only 1 mark. If you just want to write this, no more solute can dissolve in the solvent, that's cool. Okay, you get your first mark as well. Next, we'll then look into the question 2. Give a reason why the crystal form when the saturated solution cools from 50 to room temperature. We will always assume room temperature as 25 degrees Celsius. So what happens when temperature drop, right? The solubility actually would drop with temperature. So basically what this means is as temperature decrease, solubility decrease as well. Alright, part B. So this is when you need to do a little bit of math or try to understand. So in this 25 cm cube of solution, the teacher is able to make a saturated solution. So she started off with an evaporating dish which looks like this. Okay, it's just usually white porcelain in color, and this alone has a mass of 64.10 gram. And at the end of the day, when all the water has evaporated, okay, so she would have started off with 25 cm cube, and then she keep adding potassium permanganate 1 scoop and 1 scoop at a time until she cannot dissolve any further. And so we will have our potassium permanganate solution, and she leave it over a few days for all the water to evaporate. And at the end of the day, what's happening here is she don't have the water anymore, but she has some crystals on it. And the total weight of this with the crystals would be 65.35. So they are asking you then to calculate the solubility of potassium permanganate in 100 gram of water. So let's try to understand this context first. Now, first what you need to do is you want to get the difference. The difference in mass, which is 1.25 gram. And this 1.25 gram is technically only in 25 cm cube of water. In this question, they are asking you to find 100 gram of water. In water is actually quite interesting. For every 1 cm cube of water, it has a mass of 1 gram. Therefore, if you think about the density of water, is 1 gram per cm cube, isn't it? Okay, so here, what we want to do here is the first step is you get the difference. You get to find out what is the mass of crystals that has dissolved in 25 cm cube, and that's 1.25. So if you want to know what is the solubility of this substance, potassium permanganate, in 100 cm cube of water, what you simply do is you multiply that 1.25 by 4, you will get 5. Okay, so while it looks like a very lengthy question because of the context, first you just need to understand the context first and then apply it based on what they need you to find. So the difference between 100 gram and 25 cm cube or 25 gram of water is just the multiplication of 4. So with this mass of crystal that you accumulate, you multiply by 4, you will get 5 gram, and this would be the solubility of potassium permanganate in water. Alright, so that's part 1 of question 3. Hopefully this has been helpful. Follow along for the second part, which is another 3 marks added to this question. See you in the next one.